We learned how to handle moles and grams with atoms, but what if we have something besides an element? What if we have a compound? Well, all you have to realize is that within a compound, you have atoms, and if we have 1 mole of that compound, we're going to have 1 mole of the individual atoms times whatever the subscript is. So a mole of water has 2 moles of hydrogen in it. We know that mass. We can calculate that. And a mole of oxygen has a certain mass. We look that up on the periodic table and we see that that's 16 grams. So 2 moles of hydrogen we calculate as being 2.06 grams. 1 mole of oxygen is 16 grams. We just sum that together to get the molar mass of water. So water has a molar mass of 18.02 grams, so we can write this equivalency statement. 1 mole is equal to 18.02 grams. Of course, this is when we're dealing with water. And we say the molar mass of water is 18.02 grams. The unit math that we learned for dealing with elements or atoms is exactly the same. We still go number to mole to gram. Okay, we can, if we have a large number of molecules, we can figure out how many moles that is and figure out how many grams it is. We use it the same way. Here's an example. How many molecules of carbon dioxide is in 2 grams of the compound? Well, we can figure out the molar mass of carbon dioxide by summing up 12.01 grams for carbon and 2 times 16 for the oxygen, and that gives us 44.01 grams. Now, the unit sequence is going to have to be gram to mole to molecule, gram to mole to molecule. So we're going to go from 2 grams of carbon dioxide, gram to mole, remembering that it's 44.01 grams, and then from mole to molecule, remembering that Avogadro's number is always used with either atoms or molecules. And so this gives us, once we do the math, 2 divided by 44.01 times 6.022 times 10 to the 23, it gives us 2.7 times 10 to the 22. Here's another example. What's the mass of 0.5 moles of sulfuric acid? This is the formula for sulfuric acid, so it's 2 times the mass of hydrogen, the mass of sulfur, and 4 times the mass of oxygen, and that gives us 98.09. The unit sequence is going to be that we take mass, grams, to mole directly. So here's our setup. There's our given 0.5 moles. We go mole to gram, and the 98.09 is with gram, so we get 49.04 grams. So now you go ahead and try it. We've got a package of equal containing 3.2 times 10 to the 20 molecules of aspartame. Here's the formula for aspartame. What is the mass of this? Well, we're going to start with a given 3.2 times 10 to the 20 molecules. We're going to go from molecule to mole and mole to gram. Notice 1 is with mole in all the calculations that we're doing on mole to grams and mole to molecule to mole, etc. What number has to go in here with molecule? Well, that's going to be Avogadro's number, 6.022 times 10 to the 23. What number goes in here? Well, we calculate 14 times 12.01, 18 times 1.008, 4 times 16, and 2 times 14.01. There's Avogadro's number, and that's the sum of those, the molar mass here. We multiply through to 3.2 times 10 to the 20 divided by 6.022 times 10 to the 23rd times 278, and we get 0.15 grams. Remember, if you're not getting the same number that I have here, then what you need to do is watch that video on how to use your calculator. Okay, so now here's a problem for you to try. Go ahead and pause and restart it after you're finished. So in this problem, we have 250 milligram tablet of aspirin, and we want to know how many moles. So what's my given is 250 milligrams. That's what I'm starting with. What's my unit sequence? It's going to be milligram to gram and then to mole. So milligram to gram and then gram to mole. Notice I put a 1 with moles because that's a hint. You don't put any other number but 1 with mole in chapter 3 in a conversion factor. So now we just need to make our fractions equal to 1. Milli is 0.001 or 10 to the minus 3. And a mole, we use the formula here to figure out how many grams. So it's going to be 9 times 12 plus 8 times 1 point is 9 times 12.001 or 01. 8 times 1.008 and 4 times 16. And that gives you 180, which I rounded off quite a bit. Okay, we multiply through and you get 0.0013 moles. In doing these problems, remember, do not abbreviate molecule as mole. It will get you very confused. Do not abbreviate molecule at all. All abbreviations will probably confuse you. And we do not use M as an abbreviation for mole. M either means meter, or it means milli, or it means molality. And so we don't use the abbreviation M. And not only that, you'll get it confused with molecule too. The only abbreviation that we use is MOL for mole. Keep that in mind.